Well, howdy there, Internet students. It's Mr. Hermanson again. Today we're going to be doing 11.2, which is a lesson about finding the surface area of polyhedra. This little algebra review on literal equations might help you. Why don't you go ahead and see if you can do them. Check your answers, and if you need more help with it, let me know. All right, here's your answers. Let me know if you'd like to see how those solutions are formed. Okay, so surface area of cylinders and prisms, I believe. Check this problem out. Piece of string is wrapped once around an empty paper towel tube. The ends of the string are attached to each end of the tube as shown. How long is a piece of string? Justify your reasoning. Go ahead and give that a shot. All right, I'm thinking the length is the square root of 85. You can see my picture. When you unwrap a cylinder, you get a rectangle. Actually, it's not the square root of 85. I forgot to find the circumference here. So this number right here should be the circumference, which would be 2 pi. So that would change this to the square root of 81 plus 2 pi squared, which is 4 pi squared. That would give you the circumference. Anyway, the important part of all this is that this shape, this rectangle, is known as the lateral area, the lateral surface of a prism or a cylinder. And we're going to use that when we find the surface area. That'll be part of the surface area. The other part of the surface area are the bases. And the two bases are always the same when you have a prism or a cylinder. That's how you can tell which part of the base is. Even if they're sitting on the side, then these are still the bases because they're equal shapes. All right. So let's talk about how to find those areas. You could just find all 6 faces and add them up. I think there's an easier way, though, by thinking about that rectangle you get when you unwrap the prism. So the lateral part of it would look like that, and then you have the 2 bases which are shaded here. Let's call those the bases here. When you're doing a rectangular prism, there's a bunch of bottom, top that you can consider the bases, but we're going to use those as the bases, the part I shaded. Okay, so let's just think about how long this is right here so we can get all in one shot. Well, that is the perimeter of the entire prism, which would be 10 plus 4 plus 10 plus 4, or 28. So if we just take that 28, that perimeter, and then we multiply that by the height, which in this case would be 10, that'll give us that part of the area. And then we just have to add the 2 bases. And the reason I'm using this method is because this will work for finding the surface area of any prism or any cylinder. So, we're going to take 28 times 10 plus 2 times the area of one base. Now remember, I thought of this as the base. So that is 5 times 4, which is 20. So we're going to get 280 plus 40 equals 320 square centimeters. All right, so give that a shot. So find the lateral area, which are these 3 faces, and then add the 2 bases to that. All right, so I hope you realize you had to use Pythagorean's theorem to find the height of that triangular base, which was 4, right here. And so the base of that is 6. 6 times 4 is 24. divided by 2 is 12. So each of those are 12. So I did 2 times 12 there. And then the lateral area, the length is 16, which is the perimeter of this base. And the height is 12. So 12 times 16. Anyway, if you did all that correctly, you should have got 216 square centimeters. All right. So I already got you started on this formula that we're going to use. So the lateral area is just the perimeter times the height. And the surface area is the lateral area plus 2 bases. So pretty simple formula that'll work for any of these problems. So let's find that. So the surface area, we'll just use big A for that for now, is equal to the lateral area plus 2, and I'll use B for the area of a base. Okay, now the lateral area is, remember, just the perimeter times the height. So the perimeter of the base, you have to figure out which is base. That's the 2 congruent triangles. The perimeter of the base is 10 plus 9 plus 7, which is 26. So that's the perimeter. And then the height is 8. So we're going to do 26 times 8 for the lateral area. That's 208. And then we have to add 2 bases to that area. Now it's giving you the height is 8.7 and the base is 8. It's a triangle. So we're going to do 1/2 times base times height, which is 34.8. And then add those 2 together and you have the total surface area. And that gives you 277.6 square inches. All right, go ahead, you try that. So find the lateral area, which is the big rectangle, which consists of the perimeter on one side and the height of the other. And then plus the 2 bases, which are hexagons in this case. Give it a shot. All right, there's some things that we kind of needed to review there. To find the area of the hexagon, you're going to do 1/2 the apothem times the perimeter. And the little triangle right here that has the apothem in is a 30, 60, 90 triangle. And the base of that triangle is 3. And remember that the height of a triangle is 3 times the square root of 3, or the base times the square root of 3. So that's what we use for A. Perimeter, of course, is 6 times 6, 36. And then you have 2 of those bases, so we multiply by that 2. And in simplest radical form, that would look like this. Since this has a square root of 3 in it, we can't combine it with the 432. If we wanted to write that, then we could round it to the nearest 10th by just calculating that. And that is about 619.1 to the nearest 10th. All right. So one thing about right and oblique cylinders, the way you find the surface area is pretty much the same. And cylinders are the same. It's just that when you unroll it, the perimeter is just changed to now the circumference. So, so really we're going to do it the same way. We're going to take 2 times the lateral area plus 2 bases. So the lateral area of the cylinder that has the radius of 6 and a height of 15. So the lateral area will look like this when you unroll it. This is your circumference, which will be 12 pi. And then this is your height, which is 15. So I don't know why I put a 2 here, but the lateral area is 12 pi times 15. And then the base is just pi r squared. So we have 2 times pi r squared because there's 2 of those bases. And the radius is 6. Then we're going to simplify that as much as possible. And that gives us 180 pi plus 72 pi. Since they both have pi, they're like terms, we can combine them. That's 252 pi for the total surface area, which is D. All right, see if you got that. See if you can give the surface area in terms of pi here. And there's what your work should look like. All right. Finding the lateral area of a cylinder. Lateral area just means not the bases, so don't include the base. So to do that, all you have to do is find the circumference, the distance around the bottom. So we're going to do 3 times pi for that and multiply by the height, which is 4.5. 3 pi times 4.5 is 13.5 pi. All right, go ahead and try one of those. Okay, and that's your answer. All right, why don't you try some practice, and we'll talk to you soon.